Find out?
10.
10 or?
3.
3. So you could have 6 blue, 10 red, 6 blue, 3 red. Basically 6 and 3. And another combination that worked was 1 red and 3 blue. So 1, 3, 6, 10. Does that sound familiar to anybody?
Pascal's triangle. We figured it out.
Triangular numbers.
Yeah, Pascal's triangle.
Wow, that's kind of cool. So I want to ask the last group in the back to come up and share what they've been working on, because they kind of jumped into this, but then I forced them to step back and make sure they all could make sense of it. So can you just come up and share? I know we don't have time to get into the deep part of it, but what they did is instead of taking 6 for one of the tiles and n for another, they said, well, let's just give them both variables, b and r, and throw that into our probability calculations and see what happens. So can you just come up and share that briefly? And then I need to wrap up. They're going to bring out the hook.
You're talking. They came over. They're going to be like, what?
Oh, it'll face you. Turn it to face you.
Actually, I'm excited. I can zoom out because I'd like to know more about that.
Yeah. Nobody wanted. So just real quick, if you could give your attention to this group that's sharing.
So we got rid of the numbers by just using B as blue and R as red. So the probability of getting a blue, or getting 2 blues, is B over B plus R. That's taking the first one, and the second one minus 1. And we kind of group these together just so that later on when we multiply it's easier. We don't have to distribute everything. And then the red, similarly, just the top is red. So you either pick 2 blues or 2 reds. And we.
So just pause. Everyone okay with that first step?
Sure. Okay with that first step? Well, we're saying this needs to equal to 1/2. So we did a lot of algebra. Multiply the top and the bottom. The way that we did it was just seeing this as x, and this is as x minus 1, so it's x squared minus x. That way we didn't have to do all of that. Then we regroup these 2 square terms together, and then the single terms together. So they have some sort of form equal to 1/2. Then we did the cross multiply, because we know that it can't be 0 anyway, because that way the game can't work. So we cross multiply, and we did a whole lot of other math, a lot of it. And we came up to this part right here, where the difference between b and r squared equals the sum of b and r, which tells us that the sum of the total number needs to be a perfect square, because otherwise you can't square. So then we started exploring perfect squares, like, 4, 9, 16, 25. And then, what the table thing is? I can't see the bottom half of the table. See, there's lots of D's and S's. It's interesting if you look at, well, we thought it was interesting, if you look at this sideways, the S's all form a triangle, right? It's like the Pascal triangle. And the S's over here also form a Pascal triangle. So if you think about those numbers, those are the numbers.
When we saw the triangle, then we started going, well, if we had 10 and 6.